In this video, I'm going to show how to use Topaz512 tag with the CR95HF. So I have already made a couple of videos using this tag. So we have seen how to use Topaz a tag with the ACR122U reader writer, and I have already showed you that not all commands of Topaz are supported inside ACR122U. So next, I showed you about the ACR122S reader writer, and we have seen that this reader writer supports every command set of the Topaz 512 card, and I've also shown how to use the commands from ACR122S, and we have used that inside ACR1252 reader writer. So does CR95HF support Topaz 512? So the answer is yes. The reason behind that is Topaz 512 is a ISO 1443 type A tag, and a couple of things this tag is different from any other. The type A tag is the way the data is framed. We are going to see that very soon now. And this Topaz is used as a NFC forum, the type 1 tag. So we have seen this software many times in this series of videos, and this is the software that runs with the CR95 development board. So I have connected the CR95 based board, and I'm going to choose that. And if you go to this 1443A menu, you can see that there is already a Topaz menu there. So this indicates this board supports some kind of a Topaz operations. So we are going to see what you can do in this software, and in fact I've mentioned this many times. If you have to use this board, there are so many helpful tips in this software, like as soon as you select this Topaz, there are so many commands already set. So as you can see here, the protocol is set to type A, and these two commands that is something to do with the modulation or the signal strengthening. So the first thing you do here is I'm going to clear the screen, clear the logs here. So if you give REQA, so this is a very standard REQA command which you have seen many times in my previous videos. And next thing is the RID. So we have covered this concept of RID, UID in all my previous videos when I did on ACR122U. Please, I would advise you to go and see those videos. So RID, when you click on RID, you get the headers as well as the UID, and you can also try reading the block 0. If you hit here, so you can see that there is a command, and we have seen this command already in ACR122U 1252 series of videos, and this is the command, or this command is also here in this text box, and this is the command that are used to read a block. And anything extra you do here is something to do with the NFC type 2 tag. So what I'm going to do now is try to use all the commands we have seen in my previous videos, and we are going to follow this syntaxes and the help what you get from this screen, and we are going to see that you can use the full Topaz commands using this CR95HF board. So before I show you my software, I'm going to show you some of the references that are made in this documentation. What you see here is CR95HF, the datasheet, and if you just go and search for the string Topaz, and you will come across somewhere in page 27, and this is to do with the send and the receive command. So every command you send to CR95HF must end with this 28, and if you decode this number 28, it says that it is set as a Topaz send format. And as you can see here, the Topaz frames are different, where every byte in the command goes as a separate frame. And basically what it says, I'm just going to read this out. It says use the EOF instead of parity bit and use SOF at the beginning of each byte. So this is something, each byte is surrounded by EOF and SOF. So pause between bytes and assume the first byte is 7 bits, and we know that every Topaz command is 7 bits. So you have to set this bit as 1, and the other thing, the 8 indicates the last byte, which is 8 bits in last byte. So if you search further down, yeah, so this is where I've taken most of these commands. So this is the best example you can ever see on Topaz, and you just have to run these commands as it is. The only difference between what is mentioned here and what I have used is, instead of using this STMCMD, I have used the send and receive command. So this is a very nice example here. It assumes the UID as this one, and it shows the various commands you have to try, or you have to send to the reader writer. It starts from selecting the protocol, and these two commands are for optimization. You just have to send as is, and after that you got this REQA, which will return you this A2QA, and this command here is the RID command. So you get to know the syntax of these commands as well. And this is the command 78 followed by so many zeros and A8, you get this RID. After that, there's a good example on the read all command. So we have seen this read all command before, where it reads the entire 15 blocks of the tag, and there is an issue with this command here. I still haven't found any solution, but I'm going to explain that very soon. And this is the output of the read all command. Now this command is a read single byte, and the command structure. It says the read the address followed by 0 and followed by the UIDs, and you get the data, you get single byte of data. And this is the write erase command, and again reading the read command here, and write non erase command, and followed by the read command. And so you've got so many read and writes here, and if you did this information is what I have used, and this is a very helpful information for us. And if you this something which I haven't, I'm just wanted to show you that, which I've myself have not understood very well. There is an issue with getting more than 64 bytes as a response, and there is a solution that's mentioned here which I have not tried. Probably once I get this working, I'll just add a little bit of a small video later date. So you have already seen this software in all my previous videos on CR95HF, and I'm going to connect, and we are going to choose the type of the tag. I'm going to choose this Topaz512, and this is the screen, and this screen is exactly the same screen you have seen in my other previous videos on Topaz512. It is just the business layer which has been modified. The user interface is the same. So first thing going to do is the activate, and as you can see here, these are the same commands that are used in that development software. The only thing here probably it is much neater. So you can see that I've got antenna off, then selecting the protocol, and running these two performance commands, then sending the REQA and followed by the RID. So this is the data we get, and you know that every response from CR95HF starts with 80, which is success, followed by the length of this command, followed by all these, you know, the data itself, and followed by the last 3 bytes, that is the control bytes, which I have already mentioned in my early videos on CR95HF. So it just, you know, whatever I got from here, I'm decoding and showing the data here. The next thing is saying the read tag. So here what I've done is, just like the documentation mentions, I have used the read all command. Now the problem with this read all command is, so I get only 61 bytes of data. I don't get this entire 120 bytes of data. Okay, just 61. Something to do with, you know, the USB buffering. So what I have done here is, because this read tag button is going to display all the 15 blocks, I have just taken the 59 bytes here. So look at it, out of this 61, the first 2 bytes are just not used, it's not data at all. So I've got this 59 bytes. After that I have started using the read byte command. So I've been reading, you know, from block 7 and byte 3 onwards, everything from this point to this end I'm sending so many read byte commands, and until, you know, you reach the last block 14 and the byte number 7. So there's nothing, you know, nothing extra thing going on here, because we have already seen the read byte command working with the ACR122 or 1252, etc. And so just after that, you can just going to clear this and show you a few reads and writes here. So just go and first of all, let's write something. Say write this as Topaz 512, and I'm going to hit right button, and here, and if you remember or recall my previous videos, and this button Topaz 96 shows only the first segment, and we know that Topaz 512 has got 512 bytes of memory altogether. So what I have done is, you know, for writing, so I have used this the write arrays command. I have used the 8 write arrays command to send this data, and whether to use the arrays or without arrays, you can control by the mode here. So if you just go and try, you know, just going to try the same thing I'm going to write, but this time write arrays, and we know that write arrays will not erase any bit that is already in the state 1. So let us try to change this as say Broadcom, and so in theory, if I write now, you should expect this showing Broadcom, because this is no arrays, the bits are going to be merged together. And let's see, so let's I'm going to write, and you can see, you know, it's a very random characters here. Let's see what exactly has happened. So this is the command to write without arrays, and the data that we are going to write is, this is the byte address, and this 42 is what you're trying to write. However, the data you received from this is from the board is 10. So what you are written, or what you want to write, and what you get is something different. So that's the reason why these bits did not match what we wanted to write. So that's the write arrays command, and we have seen, okay, it's all the same. You can just I'm going to fill this everything to Topaz 512, and I'm going to use arrays, say write, and you can see here, you know, it's all happening using a single write byte command. Okay, So likewise, we have seen that the OTP and the logs, they're all locked. I would advise you to see my previous videos. I'm not going to cover this again here. And we have seen this the string write command as well. So eventually it's all about the write commands. Now I'm going to show you what is going to happen when you select this Topaz512. So you can see here, this time I have read all the 4 segments are shown here, and if you scroll and see what are the commands I have used, these are the commands which we have already seen in the ACR1252. And we know that there is a command called read segment, and there is an issue here because the read segment also doesn't return the entire segment, but it returns only the 61 bytes. Actually it is 64, and if you see that every response will have, say, some data followed by some 3 control bytes, isn't it? So you get 61 bytes plus 3, and out of this 61, the first 2 bytes, in this case again, the first 2 bytes are again indicates a success and the length. So what I have done here is all this data after this the block 7, and from block 7, sorry, the block 8 onwards, I have started, sorry, the block 7 onwards, I have started using the read 8 bytes command. So this is we have seen this command already. This is the read 8 commands. So it reads everything one after another, and this populates this entire grid with the data. Now it's just you can write something. I'm going to this time write something at block 16. So let's try Topaz 512, and so just write it here. Yeah, Topaz 512 write, and what you see here is I have used the write 8 bytes, which I have already seen in ACR1252. So it is just you have to keep in mind the syntax of the command. So you start with the command and the block address, followed by the data, and followed by the ID of the tag, the UID of the tag, and as you can see here, every command ends with the EA8. So this is the one that tells to use Topaz framing. And the output of, or the response from write 8 bytes is, so it starts with whatever address or byte number we wanted to write, followed by the 8 bytes from the EEPROM, and depending on whether we are using write arrays or write without arrays, and this can be different from what we sent. So I'm going to show you now. So followed by, so I'm going to try in block number 17 to write, say, Broadcom write, and this time we are using again the write array. So whatever data we sent must be the same as what we received. I'm going to write to the same block, but this time with the no arrays. So let us try to write just before that, let's go to the ASCII. Yeah, let's try to write Topaz 512 write, and you can see again there's some garbage here, and if you look at the commands that we are, it is a write 8 non-arrays, and this is the byte we wanted to write from here to here, and what you got in the response is the data that says from 1156, there's something different from. So that is how the write arrays thing works. And I don't want to mention anything about the logs here. I already explained, and in fact you can't change any of these locks because they're all already locked. So after that, it's a string again. I just wanted to, I could have shown you, just try to write, I'm going to write some lorem ipsum. So I have grabbed some lorem ipsum characters, and I'm going to, there's something missing here, probably the scroll bar is missing, and I usually don't write this much of text here. So let us try to write this. I'm going to transfer this from block 0, block 1 onwards, so you know that everything has come to the grid. So let's use with arrays and transfer everything from block 1 to block 63. So let us clear this command set. So right now everything, as you can see here, there's a series of write 8 bytes going on in the background. So everything is written successfully. So if the couple of things, okay, you have to just keep in mind. One of the thing was the read all command, so which we know that. So I still have to figure out how to get, okay, the document speaks something about the long, the long frame and other stuff. So I still have to figure out how to do that. And otherwise all the commands, which we have seen working in 122s also works here. And also, we have seen the read segment command, which is supposed to return 128 bytes, also returns just the 61 byte. Okay, so the 64 byte is something to do with the maximum size of the USB to the data that goes in the USB. So that is all we have for Topaz512. The next will be on using NTAG 213 or 215, 216 tags using the same board CR95HF. So if you like this video, give me a thumbs up and please subscribe to my channel.